We are in my shop and we're going to do a little talk about a relay or a blower control relay slash circuit board for a PSC blower. A lot of times we don't deal with PSC blowers on new equipment any longer, but when we have to retrofit a blower to a ECM motor, sometimes we go back with a PSC, as I've done in a few of my videos, just because of cost, and ECMs can be a little bit more problematic in the long run than a PSC blower. Now, I have fitted several blower controls to those PSC motors over the years, ranging from just a regular 9340 relay to a single pole, normally open relay, all the way back to the ICM 255, which we have a video about somewhere. I don't remember where it's at, but it's somewhere. We're going to talk about another relay today made by ICM that has a delay on make and delay on break for the blower. So let's take a closer look at that. The ICM 251B. Take a look at it. As you see, we have just a regular blower style relay mounted onto the board. A few other terminals and two dials here on the left side. We're going to take it out, take a closer look at it, and see what these little things mean. All right, let's take a look at the ICM 251. We have two dials here and here. As you see, we're also made in the USA, which is a good thing because it's very difficult to find. At the top, you see delay on break. After the fan call is gone, this is a post-purge adjustment to let the blower run for a certain amount of time before it shuts down. Now, as you can see, it has seconds written right here, so it goes anywhere from 12 on this end of the dial all the way around to 390 seconds, which gives you a nice long delay. You probably don't need that much, but you can decide by turning the dial, and it's got a little slotted head, so you can just put a screwdriver in it and turn it, but it's really easy to turn. And you see there's a point on the dial pointing to where it's at. Right now we're around between 200 and 390. On the lower, you see delay on make. So when a call for the fan is initiated, it waits a certain amount of time before the fan comes on. And this allows your coil to get cold or hot depending on what cycle you're in. Hot for if you have a heat pump. So you probably can't delay 180 seconds on a heat pump or else it'll go off on high head pressure. You may be able to delay 30 seconds on air conditioning so the coil gets real cold, but you wouldn't want to do it much longer than that or you start to get frost on it. So somewhere between 1 and midway between 1 and 90 is probably where you'd set that. I'd only set it for a few seconds because that's all you really need to get a coil nice and cold on an AC. Over here you see we have our L terminal here. That's our limit. A lot of the other controls that I've used in the past don't have this limit, and all it does is that you see down here we have our R running along here, and it passes through a limit switch until it gets to this L. And all that means is if that limit switch opens up, the fan will run continuously. Idea being, let's say you had a really hot heat exchanger, you need to cool it off. It'll cut power to the heat and will keep that blower running so that it'll dissipate all the heat that's on that exchanger. That's the idea. Keep it going, just like a gas furnace limit does. The R will also pass directly to the R terminal on the board, which is right over here. R is 24 volts hot from the transformer, as you can see right here. Secondary side, 24 volts AC. On the other side is the common, which will pass to the C right here. And then you'll have your G, which is your fan, 24 volts from the thermostat, which I typically use green, but I've seen them a few different colors. ICP is a different color, and I've seen different colors over the years, but a lot of times I use green on my thermostat wire for fan. So that covers all of our low voltage terminals right here and our two dials. Now we have our main fan relay, which is a lot like any other fan relay. You'll have your common, which is right here. Then you'll have normally open and normally closed. Now our common will have our speed tap for our blower, whatever speed, low, low medium, medium high, high, however they're oriented. If there's 4, 3, 2, whatever, you'll choose which one is appropriate, put it on that tap. On the normally open, You'll put your power coming in from the main lug, because it'll be switched and turned off until you get a call for fan or a call from the limit switch that needs to be turned on. Normally closed will be your wire from the heat kit or heat strips. So if the sequencer closes and there's no call for fan, it'll let the blower run at whatever speed you've chosen. So it's pretty simple, but it gives you a little extra control with the post-purge, delay on break, and the delay on make when it first gets the call. So it's a nice control, it's relatively inexpensive, and you can retrofit it for many applications. So I think it's pretty good to have whenever you're doing that sort of thing with an ECM motor replacement or just an older air handler that uses a PSC blower and the relay goes bad. You can go ahead and put this thing in. Or if you're changing relays whenever you change a motor, you can put one of these in as a replacement control. So that's it, guys. This is the ICM 251, a real good control, low cost, made in the USA. Hopefully something you can depend on for a few years as truck stock.